All right, ladies and gentlemen, this is going to be your electrostatics calculation test portion review. It is coming from the additional exercises that you got from me in class. I'll remind you your test is Friday, January 28th or Monday the 31st, depending on whether you have me A day or B day. I will also tell you your BOPs 4.1 are online. If you're already online, go and print them out. Also, read over your notes and your statics worksheet number 1 and 2 for your multiple choice and fill in the blank section. That'll help you prepare for that. Now, I'm not doing all of the problems. I'm just going to do some of them on this review. So let's get started. Okay, the first one that I'm going to start with is number 1. Okay, number 1 and 2 are very similar, so I'm just going to do number 1. So let me start with my color over here, number 1. On number 1, it talks about a raindrop acquiring a negative charge of 3 times 10 to the negative 18th coulombs as it falls. Well, our symbol for a charge is Q, so I'm going to say negative 3 times 10 to the negative 18th coulombs because I'm going to identify my variables as I go along. What's the force of attraction? So I'm looking for a force of attraction when the raindrop is 6 centimeters from the bulb on the end of a car antenna that has a charge of, so we have a second charge. This is of my raindrop and this is of my bulb. Okay, and our second charge is going to be 2 times 10 to the negative 6 coulombs. Now, we were told a distance that they're apart is 6 centimeters. Well, we're not allowed to use centimeters, so we have to convert. We have to divide by 100 centimeters, so that's going to be 0.06 meters. Now, our formula is F equals KQ1 Q2 divided by D squared. If that's the case, then this over here would be my Q1. This could be my Q2. Now I also have a K constant. This number is always the same, and it is 9 times 10 to the ninth power. All right, so now all I'm going to do is plug in numbers. So I have 9 times 10 to the ninth multiplied by negative 3 times 10 to the negative 18th coulombs multiplied by 2 times 10 to the negative 6 coulombs divided by 0.06 squared. Don't forget to square your units on that. All right. So we are looking for a force. And so once we do this, um, you'll end up needing to use your EE button in your calculator to do your times 10 powers. You should end up with a negative 1.15 times 10 to the negative 11th. And since it's a force, it has the units of newtons. All right. Now, it's a negative force because it's actually pulling towards the, because the two objects are coming together. Okay, and that distance is going to get smaller in the force. All right. So number 2 is very much like this. You'll do it the same way. You're given two charges, you're given a distance, you know your K, find your F. Let's move on. The next problem I'm going to do is number 3. Number 3 and number 4 are very similar to each other, so they will actually be done the same way. After unpacking a shipment of lab glassware, Mrs. Payne dumps a box of styrofoam packing chips into a recycling bin. The chips rub together, and two chips that are a distance of 0.015 meters apart repel each other with a force of 6 times 10 to the negative 3 newtons. And I want to know what the charge is of each chip. Okay, well, again, we do know K. K remains the same. It's our electrostatic constant, and it is going to be our 9 times 10 to the ninth. All right. Well, our formula is F equals K Q1 Q2 divided by D squared. The issue here, though, is Q1 and Q2 are going to be the same. So we could recombine this to be F equals KQ squared divided by D squared. To solve this problem, we'll need to take our force, which is 6 times 10 to the negative 3, equals our 9 times 10 to the ninth q squared divided by 0.015 squared. Problem with this unit is that you guys are going to lose those squared. Don't lose them. We're going to cross multiply, and when we cross multiply, we should end up with, I'm doing number 4 and not number 3. I hope somebody is hollering at me. Okay, so I'm going to just go ahead and continue with number 4 because it doesn't make sense for me to go back. Yeah, I've done all the information for this one. So we're going to cross multiply, and sorry about that, y'all. When we cross multiply, we get 6 times 10 to the negative 3 multiplied by 0.015 squared divided by 9 times 10 to the ninth equals q squared. Well, we have to get rid of that squared. So to get rid of that squared, we have to take the square root of both sides. So when you do your math and you take the square root and you remember to square your 0.015 in your original calculation, you should get an answer of 1.22 times 10 to the negative 8th coulombs. Again, sorry about that. That was number 4 and not number 3. All right. But again, they're done the same way. So you can combine the Q's and then you just solve for Q because you're solving for the charge of each of them and they will have the same charge. All right. Moving along. We're now going to do number 5. And yes, I will write the number up here and I'll actually read number 5. Wiz the cat is battling at 2 ping pong balls, gotta love Wiz, hanging from insulated threads with their sides barely touching. Each ball acquires a positive charge of 3.5 times 10 to the negative 9 coulombs. So that's Q1 and it's Q2. Both of these equal 3.5 times 10 to the negative 9. And that is coulombs. From Wiz's fur, and they swing apart. They should swing apart because they're both a positive charge. If a force of, so force is 6 times 10 to the negative 5th newtons, acts on one of the balls, how far apart are they from each other? So we want to find the distance. Okay, so this is just for part A. Now, the formula is F equals KQ, and these are the same Q's, so we're going to say KQ squared over D squared. This time we're trying to find D by itself, though. So we're going to do our math, and when we do our math, we should get D equals the square root of KQ squared divided by F. If that's the case, we know that K is 9 times 10 to the ninth, because that's a constant. Our Q's are going to be 3.5 times 10 to the negative ninth squared divided by our force, which is 6 times 10 to the negative fifth. We then have to take the square root of all of this. When we get our answer, it should be 0.04 meters, or we could even say 4.29 times 10 to the negative 2 meters. Either one of those answers would be counted correct. Now the second part of this is the force between them one of attraction or repulsion? Well, since they are the same charge, that's the thing to realize, they are like charges, and the basic law of electrostatics says that like repel. So this is repulsion. Okay. Remember that's your basic law of electrostatics, that like charges repel and unlike charges attract. Continuing on. The next one I'm going to do is number 7. So let's go to number 7. In the human body, nerve cells work by pumping sodium ions out of a cell in order to maintain a potential difference across the cell wall. If a sodium ion carries a charge of, so we have a Q of 1.6 times 10 to the negative 19th coulombs, as it is pumped with an electrical force, which we call F, it's still a force, all right, of 2.0 times 10 to the negative 12 newtons. I want to know what the electric field between the two is. Well, the formula for electric field is E equals F over Q. That's all we have to do. We were given F, we were given Q. So in order to solve for E, all we're going to do is plug in. Our F is 2 times 10 to the negative 12, and our 1.6 times 10 to the negative 19th, which when we solve on number 7, it is 1.25 times 10 to the 7th. Now this was newtons and this is coulombs, so the units is newtons per coulomb. Now it is important that you realize with number 7 is just like number 6. So number 6 and number 7 will be done the same way. Okay, so realize that number 6 and number 7 are the same type of problem. All right. Continuing forward. The next problem that I'm going to do is number 8. Number 8 has us dealing with 2 Van de Graaff generators whose centers are separated from one another by 0.5 meters. So I have Van de Graaff generators have big spheres on the top of them, and their centers are separated by 0.5 meters, right? All right. They become charged after they are switched on, and one Van de Graaff generator holds. So I'm going to make this one number 1 and this one number 2. So this one's going to hold a charge of 3.0 times 10 to the negative 2 coulombs. And this one's going to hold a charge of negative 2 times 10 to the negative 2 coulombs. What is the magnitude and direction of the electric field halfway between them? So halfway between them, I want to know what the electric field is going to be. Well, the issue on this one is we have to realize that we are going to solve for the electric field, which is roughly going to be our E equals KQ over D squared for this one, and I want to find the electric field for this one, which will be KQ over D squared. Now you need to realize that the D that I want to use is 0.25 meters because I'm talking about halfway in between. Now, this one on this side, let me draw this number 1, the number 1 Van de Graaff generator, has a field that is pushing that direction because it's positive. So if I dropped an electron, actually if I dropped a charged particle, a positive charged particle in its field, it would be pushed away. It's going to repel. Now, since the charge of this one is negative, then if I drop a charged particle in it, it's going to go towards it. Okay? Since they're going in the same direction, to find the electric field total, I'm going to go ahead and do E1 plus E2. You always drop a positive particle. Okay, and when you drop the positive particle, you have to look about which way it's going to go because of the charge that it has. So since this one was positive, if you drop a positive particle, it's going to go to the right as we're looking at it. If you drop a positive particle next to number 2, it's going to go to the left, or it's going to go to the right as well because it's going to be attracted to it. All right. So we have to say 9 times 10 to the 9th multiplied by our charge, which is 3 times 10 to the negative 2, over our distance, which is 0.25 squared, plus 9 times 10 to the ninth, and we're going to go ahead and do 2 times 10 to the negative 2. We're not going to use that negative there because that negative was really just to help us know about the direction that's going to travel. So that was used primarily to help us figure out whether we were going to add or subtract these two together. So we're going to go ahead and disregard that negative after we figure that out. And we're going to use 0.25 squared here as well. So you should get 4.32 times 10 to the ninth roughly here, plus 2.88 times 10 to the ninth here. When you add them together, you get 7.2 times 10 to the ninth. This is newtons per coulomb. All right. Now it is moving to the right. That is our direction because that is the because Q2 is a negative particle. So it is moving towards the right. So this is our magnitude right here, and this is our direction because all of our arrows are pointing to the negative charge. All right. Let me see if I can get. Actually, I'm going to stop there. I know I haven't done all of them, but I'm going to go ahead and need to do another recording because I don't want this to be too much to actually add to the web. Okay? So pull up the second one as well, and I'll continue with problems 10, 11, and 12. See you soon.